Alright, so this time we're doing problem 95 from chapter 6. The problem says, based on the given data, how does the energy used in walking 1 kilometer in biking 1 kilometer compared to that used in walking 1 kilometer? And the information we need to know before for the question says, on flat ground, a 70 kilogram person requires 30 watts of metabolic power to walk at a steady pace of 5 kilometers per hour. Using the same metabolic power output, that person can bicycle over the same distance at 15 kilometers per hour. And then the question wants to know, how does the energy requirements compare to bike 1 kilometer compared to walking 1 kilometer? And it gives us 4 options. Option A, it takes 1/3 of the energy to bike it, then of how much 1/3 of the energy you would use walking it is what you would use biking the kilometer. Option B is the same energy as walking. On option C is 3 times the amount of energy that it would take to walk. And D is 9 times as much energy that it would take to walk to bike it. So, kind of logically right off the bat, we can say that C and D are out. Because if it took more energy to bike than it took to walk, everyone would bike places, they wouldn't walk somewhere. To the same extent, you can almost say that if it took the same equal amounts of energy to walk and bike, they probably still wouldn't do it. Unless, of course, you just really like going fast, and then those people are still gonna bike because they get to go faster. But we can do some math. So we know that they're going the same distance, but they have 2 different velocities that they're going. So if we take the 1 kilometer divided by the velocity, it'll tell us the amount of time that it would take. So 1 kilometer divided by the walking speed of 5 kilometers per hour is going to be equal to 0.2 hours to walk that distance. And then 1 kilometer divided by 15 kilometers per hour is going to give us 0.067 hours. So already we can see that it's going to take a lot less time to bike that distance than it is to walk. We're then given a unit of energy for how much energy you have to exert to go these velocities. And it's the same amount of energy for each velocity. So if we then take the difference between these two, so 0.067, the time that it would take to bike it, divided by the time that it would take to walk, because our answers are in the reference of comparing to how much time and energy it would take to walk it. We get that comes out to 1/3 of the time. Time times the power will give us the work. So, 1/3 times, and it's going to take the same energy, so 1/3 of the time to bike it times, so it's going to be 1/3 of the energy, because it's 1/3 of the time to bike the distance as it is to walk the distance.